Alright, so we're going to work example 25-1 in your textbook. That's page 763. Alright, so we're given G1 of 3 plus 3.1. So that is G1, 3.1. We're given G2, a negative 2.40. We're given the V, vertex, station 46 plus 70. We're given the elevation of 853.48. And this is an equal tangent parabolic curve, 600 feet. So 600 feet would be actually 6 stations. So we want to first go ahead and do our R. So R equals, and R is the equation 25(4), which is G2 minus G1 divided by, and I'm going to put L in stations. So G2 is a negative 2.4, subtract a 3% over 6.90. So that's our R. One thing we're going to want to know actually is if you get this number and it's like a repeating 0.66666, keep it out to 4 decimal places, because if not, when we're checking, it comes up kind of funny. Alright, so next we've got to get the stationing. Stationing is kind of just like the stationing in the horizontal curves. So they give you the V, 46 plus 70. So you can either do 4670. You're always, this one's equal, so each side, the station, is going to be, to get the begin vertical curve, that's going to be minus L over 2. So always half your curve. That's a 300. So the beginning vertical curve station would be 43 plus 70. So you would always subtract it. If I want to do it this way and take the pluses out, it would look like that. And then I would come back in and just put my plus in between. Alright, and then to get the invertical curve, it's always going to be plus L. And our L is 6 stations, or 600 feet. So our end vertical curve will be 49 plus 70. So those are the two numbers I need right now. Now I need to know what the elevation right here at the beginning vertical curve is. So we're just going to do a straight line grade from the 46 plus 70 on a 3% down to get to this stage, to get this elevation. So I'll show you how to, this one I always do the beginning and the end one. So elevation at the beginning vertical curve is always going to be, you're going to use your elevation of V, which is 853.48. If you'll always do a minus here when you do your beginning vertical curve, it doesn't matter if you keep your symbols, it'll always work out right for you. So this is actually a 3%, and you're going to multiply it by your L over 2. So remember, if it's 6 stations, we have 3 stations on the left and 3 stations on the right. So this would be 3. So this is actually L over 2. This is always your G1, and you're going to always put the negative in there. And that'll give you 844.48. Now I'm going to go ahead and do the elevation at the end vertical curve. So I'm going to go back to your elevation at V. So I'm going to write that's elevation V. So 853.48. If you'll always to do the end one, do a plus. My G2 is a negative 2.4 and L over 2 is 3. And that would be 846.28. That's kind of a check for me. Alright, so from this point, that means I've got to, if we've got our begin vertical curve elevation at 43 plus 70, it's a 600-foot vertical curve. The end is 49 plus 70. I want to set this up in a chart. So I want to kind of set it up just like this. So I'm going to set up, if you set it up in a chart, I'm going to scroll. Alright, so I'm going to put 43 plus 70 at the bottom. That's my beginning vertical curve. If we want to stake it every 100 feet, it does not mean put 44 plus 70. You want to go to the next even station. So 43 plus 70, and the next even station is 44. So if they say every 100 feet, 44, 45, 46, 47, 48, 49, and 49 plus 70. So once we've got that set up, that's all you have to do. Then the next column you always want to write in is X, and that's in stations. X is always the distance from the station that you're wanting the elevation back to the beginning vertical curve. So for example, the 44, so I'm going to put a 1 here. So column 1 is always X in stations. And that's the distance I'm going to say distance to beginning vertical curve. So if we're looking at 44 plus 0, 0 minus 43 plus 70, it's actually 30 feet, but that is equal to 0.3 stations. So you just divide it by 100 to put it back in stations. So there's 30 feet here, so that would be 30 divided by 100, 0.3. Now for the next one, we're going to 45. So for the difference between 45 plus 0, 0 minus 43 plus 70, that leaves me 130. 1 plus 30. Sorry. So 1 plus 30, if you divide that by 100, would equal 1.3 stations. And so when you get here, this kind of is repetitive. You're just going to add 1 because each time it's going to be 100. So if I'm at 1 plus 1.3 2.3, 3.3, 4.3, 5.3. And then if you take the difference between 4970 and 4370, it should be 6. So it's a little different. So the next column is column 2. So I'm going to put a 2 right here. And that's always going to be G1 times your X. So we've already got the X's figured, so that's what's great. So I'm just going to look back, and they gave us G1 in the problem as 3. So to do the next column, it's going to be, so for example, 44. That column 2 would be 3 times my X of 0.3, and that gives me 0.9. If I go to 45, so the only thing's going to change, so G1 is 3, and my X for that one is 1.3, and that gives me a 3.9. So you'll go ahead and do that for the remaining to each station. So the only thing that's going to change is your X. So not too bad. And then my third column is going to be Rx squared divided by 2. So I'm going to write column 3 is Rx, and we've already got X squared divided by 2. So our R was a 0.9. So remember, we solved that back in the beginning, is 0.9. So if I'm going to go back and do station 44, it's going to be a negative 0.9. X is going to be the same that's in column 1, so it's going to be 0. Oh, sorry. Must have been holding something down. I really got a mess. Hopefully I can get this figured out. I'm hoping I just okay, so we're back now. Alright, so a minus 9. My X is 0.3. Remember, this has to be squared, divided by 2, and that will go in my next column, and so that's going to give me a negative 0.04. I'm going to punch that in. Now typically if it gives me a number that worked out to be 0.0405. If my 9 was a rounded number, typically I would keep it all the way out, but this one gave me 0.005. But when we're usually working with grades, we only do them, especially the English units, to 2 decimal places. I just noticed that if that R was any repeating, it kind of would throw off the other. So I want you to be really careful about when you're doing your calculations to keep them at least your R, keep your R out to 4, and then you can round when we get to the end. Alright, so next column is just going to be Rx squared divided by 2. So the only thing that's going to change when I go to station 45 So my r is negative 0.9. 1.3 squared divided by 2. And that gave me a negative 0.765. Alright, so as you see, you'll just add those in as you go along. So again, there's nothing on the first line, and we'll use the rx squared divided by 2, and we'll get these answers and put them in the chart. And then the last one is the curve elevations. So I'm going to go back and show you this one equation in just a minute. So we've got the beginning vertical curve was 344.48. And we solved that right here, 344.48. Now if I scroll up to the equation right here, 25.5, it says if I want to solve for any elevation on the curve, it's going to be your y, which is your elevation of your beginning vertical curve, plus g1 times x plus rx squared, or I call it rx squared divided by 2, or r over 2x squared. So if you noticed, when we go over here, that's why we have the columns. Now, we have the g1x column, which is 2. We have the rx squared divided by 2 right here. So if I want to do station 44, I'm going to write the equation out for you first. So y means that's the elevation of the station in question. It'll be the elevation beginning vertical curve plus g1 times x plus, and they kind of write it like this, but it's exactly the same thing that we have in our column 3. Alright, so if I'm looking at 44, my beginning vertical curve is 844.48 plus g1 times x. So do not pick up this first column. The only reason we did the first column is just to get x to be able to calculate column 2. So the first column I'm going to actually add is the g1 times x column. So that'll be 0.9 and then plus a negative 0.04. So we're going to take our beginning vertical curve elevation plus our g1 times x, which is our column 2, plus our column 3, and I'm going to write column 2 and 3 here. And when we add that, we should get 845.34. So that go down to 45 plus 0, 0. The beginning vertical curve's not going to change, so that's 844.48 plus, and for 45 that is a 390 for column 2 plus a negative 0.76, and we'll get 847.62. And so you'd go ahead and do all of that till you get to the end. So I'm not gonna and then I'm gonna do the last one, which is the 49 plus 70. So I have 844.48 0.48 plus 18 plus a negative 16.2, and you should get 846.28. Now, I actually calculated that up here at the beginning. The in vertical curve elevation, I got 846.28. So I did it by the straight line grade, and then we did it by using the notes for the curve. So these elevations, what we're calculating is what the vertical curve grade is right here. Right here. Let's see if it'll let me. It's given us the grades for the curve. It's not gonna let me write on that, sorry. So it's given us the grades right here. 45. I want to know what the curve grades are along the curve to be able to stake out the asphalt. I don't want the straight line grades. I want to be how we've smoothed it out. So we're actually solving for the grades that actually fall on top of the curve. So here, 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 and the end. So not too bad. So we can check our work. So I am going to show you how to check the work. I would only check my work maybe on a test. And you can check your work for first difference and second difference. So typically when you're setting up your homework problems, I would only do these first 4 columns. If I was doing this on a test, I would do my first difference and second difference, because what we're going to do is we're going to see that this number should come out to R if we've done our calculations right. Now, to do the first difference and second difference is a difference in between numbers, but you can only do this for 100-foot stations. So I cannot do it between the 4970 and the 49 because it's not 100 foot. That's only 70 feet. So the very first one that I'm going to do the difference or check for will be between the 49 and the 48. And you always want to start at the top. So I'm going to show you. So if I start at the 49, I'm going to write what the elevation is. They have 847.74, and at 48 they've got 849.06. So you'd want to take a difference between these two numbers. So you always start with the top one in stations minus the higher station minus the lower station. There's where that negative comes into play. So if I take 847.74 and I subtract 849.06, and subtract 849.06, that gives me a negative 1.32. So that's called your first difference. And then you have a second. So 47, I'm not going to put the pluses. So you can do this for 45, 44. So that's where it's going to stop because I can only do it for 100-foot stations. 849, 48. So I'm going to put it in. Now, like I said, for homework, I'm going to show you how we can check it using the Wolfpack software that came with the book. But I wouldn't, this is a lot of work for a test. I definitely would check it just to make sure I don't have anything wrong. Alright, so we're going to do a second difference now between 48 and 47. So I'm going to take the 849.06 minus the 849.48, which will give me a negative 0.42. First, and this is a difference, so again I'm going to take 849.48 minus 849, and I got a 0.48. And then 849 minus the 847.62, and the last one, 847.62 minus 2.28. Now we've got a second difference. This is where we're going to check the difference between the two numbers. So if I say a negative 1.32 minus a negative 0.42, that gives me a negative 0.9. So again, what I did for this one is I took my negative 1.32, the difference is always subtracting, and I subtract a negative 0.42, which makes it a positive, leaves me with a negative 0.9. Alright, so now second difference for this one would be a negative 0.42 minus a 0.48. And again, you're going to get a negative 9. For this one, it's 0.48 minus a 1.38, which gives you a negative 0.9. And this one is 1.38 minus a 2.28, again, negative 9. So there's how I can check that all of my work is correct for this. So that's definitely a way of checking your work and making sure that it is correct. Alright, so that would be everything that we would need to do. That's checking it, that's listing it. The very last thing would be doing a high point or a low point for this. So I'm going to look at that curve, and actually I can see it curves up and I see it starting to go down. That means I've got a high point. So let me come down and make me some room on the paper. Let me save this before I've got a mess. Once I save it, I may just pick it up and show you in the next one how to actually do that, and I will.